Leclerc Group actually had a desire for growth. It's our headquarters is out of St. Louis, Missouri, and so 2012 is when they started to kind of venture off on this growth effort. So Leclerc Group actually purchased a company nearby called Missouri Energy in Kansas City, and then in 2014 we purchased Alagasco, which covers the Birmingham and Montgomery area. And then we came on board in 2016. And so those five companies today is formed into Spire. The company rebranded instead of being so chopped up with the different names. That's how Spire came about. And so we have a focus, our four objectives are growing organically, investing in infrastructure, innovation, technology, and acquiring and integrating. Our mission, as you can see, is to answer every challenge, advance every community, enrich every life through the strength of our energy. This gives you a snapshot of our market. The five gas companies I mentioned across Alabama, Mississippi. So Wilmot Gas was also came on board with us out of Hattiesburg, Mississippi. So we have about 1.7 million customers. We're the largest gas company in Missouri and Alabama. So not just the utilities, there's storage, there's the STL pipeline venture. We have marketing firms in Houston area. So that kind of gives you a snapshot of who we are. We have a focus on safe and reliable service, community development, and growth. So why natural gas? For one, there's an abundance of natural gas here in the United States. It gives us energy independence. And so there's more than 100 years of natural gas already discovered, 100 years of supply. It's reliable, as I mentioned earlier. Through most catastrophe, natural gas is going to be there. So it's very rare there's an interruption. It's efficient. 91% of the gas that's discovered makes it from the site to the source, so very little waste. And as you can see from this slide, natural gas emits 56 fewer greenhouse emissions than coal. And so the lowest carbon emissions in decades. In 2016, natural gas accounted for more than 33% of electricity generation, and that continues to grow. And that's a good thing because the CO2 levels is much less with natural gas compared to coal. And you can see here on the slide, 129 pounds equivalent with natural gas compared to 212 pounds for coal. So quite a significant difference there. So our company, guys, we have a goal of becoming carbon neutral by mid-century. And the way we're doing some of that, it's upgrading infrastructure. We replaced 3,900 miles of infrastructure or pipeline since 2005. We've had a tree planting effort. We planted 900 trees throughout our service territory. And we've actually hired an environmental head to have a concerted effort on making changes and improving and actually accomplishing that goal. And so it's the right thing to do for our company. It's the right thing to do for our community. And so that's kind of where we are with that. So becoming carbon neutral by mid-century. This is my contact information, guys. So if you have any questions or, my sector that I'm responsible for is large commercial and industrial. So if you're a customer and you need assistance with your current account, feel free to reach out to me, or if there's expansions and growth, or if you would like to become a customer, feel free to reach out to me. I'm here to help. So that's my contact information. And that's all my slides. Thank you, Jennifer.
Thank you, George. I'm going to jump in just real quick before David speaks. If everyone could put your mute button on, that would be great to eliminate any background noise, even if you're on the phone. Again, sorry to interrupt, but George, thank you so much for that great information. And now David Schad will introduce our speakers.
Okay, thanks, Jennifer. I'm excited to introduce two dynamic speakers here that will entertain us for the next 45 minutes. But first is Bruce Fox. Bruce is a certified project management professional and safety trained supervisor with over 30 years of diverse construction remediation experience. including more than 20 years of experience as managing federal environmental demolition and construction projects. He has an excellent working knowledge of the Department of Energy, U.S. Army Corps of Engineers, and commercial client performance requirements. His experience includes heavy civil construction projects, large-scale demolition, excavation, and disposition of radiological contaminated soils, commercial manufacturing facilities, concrete tilt structures, and site remediation and restoration. And secondly is Rick Green. Rick has over 43 years of experience in health physics, starting with a research associate at Oak Ridge National Laboratory. He has written radiation protection plans for numerous types of facilities and projects, been responsible for obtaining radioactive material license, and has assisted clients with regulatory negotiations. He has served as the radiation safety officer on licenses including radioanalytical, mixed waste and treatment test laboratories, service provider license, and D&D license. So, gentlemen, thank you for joining us today, and we'll turn it over to you.
Thank you, David. Thanks for that kind introduction. Jennifer, again, thank you for opportunity to come and share this project. Thank you for the invitation. So we're excited to be here and tell you about what's coming. We've met with many of you already over the past several months. So Rick is going to share his screen, put a presentation up here in just a couple of minutes, and then we'll walk through it. Let me start, while Rick is putting that up, let me start with a safety topic. At APTIM, we always start our meetings with a safety topic. So let me do that. We still can't see your screen there, Rick. So let me start with the safety topic. There it is. All right. In today's world, we travel. We at APTIM, we travel a lot. So my particular schedule is getting less and less predictable nowadays, and I'm not sure if I'm going to be in a hotel or a conference room or an office building or my home. As you can tell from my background now, I'm in a hotel today. So it's important as we do move around so many different places to know our surroundings, know our exits, all in the context of keeping ourselves safe. In the event of a fire or a fire alarm or other emergency, we need to know where the exits are. We need to know how to get to them, the routes to the exits. We need to make sure they're clear of any tripping hazards, make sure that we can get out of a facility in the event we need to during an emergency. Once we get out, we need to know what to do then, where to go, where to rally, go to a parking lot or other area away from the structure until the emergency can be resolved, fire, police, whatever it might be. While we're inside the facility, just take note of where the fire extinguishers are. This could even apply to your homes. If you have fire extinguishers for your kitchen or your garage or whatever, make sure that they're accessible, not blocked, that you can get to them. And if you are traveling with a group, make sure you have your points of contact with you so that when you do rally in the event of emergency outdoors somewhere, you can do a head count and make sure everyone's accounted for. So that's just a quick safety topic on different areas that we travel and just being aware of your surroundings. All right, hope that helps someone. Let's get started with our presentation. We're going to talk this morning about the SSSB Project, Surface Ship Support Barge project. And again, we've done several presentations to different groups. I'm pretty sure we've got a slide about that here coming up later on in the presentation as well. So what is it? What is the project? This is an overview of the project. It's a contract we have with NAVSEA. This vessel was originally located out of Newport News, Virginia. It was originally a World War II T2 tanker. In the mid-60s, it was rebuilt, reconfigured to support refueling of nuclear aircraft carriers. It supported 8 different carriers, and we've listed those there. Supported the Enterprise 3 different times, the Nimitz, Eisenhower, Vinson, Roosevelt, and the Lincoln. And so it was last used on a refueling evolution in late 2015. And since that time, it's been in dry dock at Newport News, Virginia. The vessel is not suitable for open ocean water towing. It must be transported. Aside from getting rained on, it hasn't been wet since 2015, up until April of this year when we took possession of it and started this project. So our scope of the project is to relocate the vessel from where it was dry docked in Virginia to a suitable decommissioning site, and that's Mobile, and remove all the hazardous and radiological impacted materials throughout the decommissioning process, and release what clean materials we can for recycling. And so that begs the question, what are the hazards? We're going to talk about that on this presentation. Just at a high level for this slide, low-level radioactive waste. Rick's going to get more into detail about that as we go. Lead paint, just like older homes that have lead paint, this old vessel has some lead paint concerns. So we're prepared to address that. Some asbestos. A lot of the asbestos, or a lot of the insulating materials early on in this vessel were asbestos-containing materials. A lot of that's been replaced with different upgrades that the Navy have performed on this vessel, but there may still be some. We've done an asbestos survey. We don't have those results back yet, but we anticipate handling some asbestos. And so we also anticipate handling some PCB product through oils in old transformers, old motors, electrical motors, even in some older light ballasts. This facility has a wet pit where the spent fuel rods from these naval vessels were transferred into, and that's where the bulk of the radioactive contamination is contained on this vessel. And it was basically a large pool, and it at one time contained 150,000 gallons of chilled water. And since we've taken possession of the vessel, the Navy has reduced that volume down to about 8,000 gallons. So that risk is significantly reduced. So that's an overview of the vessel and an overview of the project. So let's get into a few more details. Let's talk about who is going to be performing the work with us, who are teaming partners, and what we bring, what they bring to the table with us to execute this project successfully. APTIM, just a quick background on us. We're a global remediation and decommissioning firm. Have a lot of D&D projects, a lot of experience, a lot of background in this area. The photo on this slide here is a picture of the Sturgis. This is a vessel that had a reactor on board, and it was actually used as the main power source for the Panama Canal for approximately about 10 years. Once the canal was upgraded and permanent power was available, this vessel was no longer needed to power the canal. So the government decommissioned this vessel. So in 2017, APTIM, we completed the decommissioning of the Sturgis reactor. So it was the first of its kind. And now here we are, the SSSB. This is a follow-on. And Rick's going to share a little bit more detail about the differences between these two projects. They're both vessels, but there are some significant differences in the two, and Rick's going to talk about that a little bit more in the presentation. Alabama Shipyard, where we're bringing the vessel. I'm sure most, if not all of you, are familiar with Alabama Shipyard, right there in Mobile. They have the dry dock and the land capabilities to support this large project. So we're really excited and really glad to have them as partners in this project as well. Burrard Transport, they're the heavy transporters that we've hired, the experts in heavy hauling. They do a lot of work with Austal, also in Mobile. So we've hired them to transport this vessel for us, and we'll share a little bit more about that as we go. Veolia, they're a global NRC licensed company. They're owner of operator of a NRC licensed facility. Have done a lot of decommissioning of nuclear vessels in the UK and France. So we've hired them for their expertise. They're a great partner to have on the project as well. They'll be doing our waste packaging for us. WCS, owner operator of the largest NRC storage facility, licensed facility. And we're glad to have them on board as well. All this waste will be going to WCS in Andrews, Texas. So a licensed facility there. And our last partner listed there is Renuke. They're a veteran-owned small business specializing in radiological support services. They'll be doing our radiological support, RCTs, radiological control technicians, providing our labor for our RCTs in the field as we go. So those are our partners, and it's just a great team. We've assembled some really strong horses to execute this project. So possession, transfer, and wet tow, Newport News Shipyard to Colonis Shipyard. Again, this is our heavy transporter. What the picture you see here is on the 18th of April of this year. That's the James River outside of Newport News, Virginia. The Navy flooded the dry dock, brought the vessel outside of Dry Dock 2 in Newport News, where our tugs, with assistance of Burrard Transport, hooked onto it, spun it around in the river, and we towed it about 15 miles out the James River, up the Elizabeth River to Colonis Shipyard, where we spent some time with it there, preparing it for the sea tow. And that's what you see on this slide here. A lot of preparation goes into a vessel, according to the Navy towing manual, in order to have it seaworthy during a blue water tow. Again, as we mentioned, this vessel by itself was not worthy, was not stable and suitable for a blue water tow. You can see it has no pointy end. I started to say it has no bow and stern. It does, but it's square butt ends on both ends. So it's not suitable for ocean tow. So we had to put it on a heavy lift barge. So the picture you see here is the SSSB on a deck barge, 400 by 100 deck barge. It's secured on there with these stanchions that you see in the photo here. All of the materials and equipment inside the vessel have been secured, tied down with chains and ratchet binders and straps, and so none of it's going to shift and move about during the ocean sea tow, during the wave action during the sea tow. The inset to this photo here in the upper right hand shows our tow route. We'll come out of the Chesapeake Bay, down around the East Coast, down around Florida, and up into the Gulf of Mexico, up into Mobile Bay, up to Alabama Shipyard. We started the sea tow yesterday. Today's the 20th, right? Yeah. Yesterday we got underway. We towed the vessel underneath the Berkeley Bridge in Norfolk and out the James River, out to Chesapeake Bay, and out into the ocean. And as of 6 a.m. this morning, the vessel is just south of Virginia Beach and underway, headed south along the East Coast. We've also got a website here for you for those that are interested. You see it here in the lower right, current location. There's an app that you can download on your phone. It's called Find Ship, all one word. And that's an app. Some of you may know about it and use it already. Don't know, but you can go to that app and you can type in any vessel name and it'll pop up on your screen to show you where it's at. So the main vessel that we have two tugs towing this vessel from Virginia to Alabama. The main tow vessel is called the Ocean Tower, and it's listed there. So if you care to, you can download that app and track it just like we are down around the East Coast. So our route is keeping the vessel within 45 miles of the coastline, all the way down and around Florida and up into the Gulf. The reason for that is if we do encounter some weather, we want to be less than or a maximum of 8 hours sail to the closest safe harbor. So we have certain restrictions through the tow plan that we generated. If our seas exceed those restrictions, we'll be going into safe harbor. We have 8 or 10 different safe harbors identified along the sea, along the tow route that we've already made arrangements. We've already contacted the captains of the port at various safe harbors along the way. So if we have to get in and get out of the weather, get off of rough seas anywhere along the route, we've already made those contacts, we've already made those arrangements, and it's just a quick call and in we go. So we're looking at the weather forecast 5 days ahead in anticipation of weather, so that we do have plenty of time in the event we need to safe harbor that we can before we actually encounter any rough seas. The voyage is scheduled to take about 17 days. So right now we're anticipating arrival in Mobile sometime on or about the 6th of June, the 4th through the 6th, sometime about that time frame. Okay, so that's a little bit about the tow prep and the tow. So Alabama Shipyard on Pinto Island, this is a photo of that. This is where we'll be going. We'll come up into the bay and up into the mouth of the river and up to Alabama Shipyard. And we'll actually take the vessel out of the water and transport it up onto the land, onto blocks for the decommissioning effort. So the time that we took possession of the vessel on the 18th of April and towed it that 15 miles or so from the James River into the Elizabeth River to Kelowna Shipyard, that was the last time the vessel's ever going to be in the water. It's all the rest of the project is going to be accomplished with the vessel up on land. Okay, so that's where we're headed with. All right, what's the next slide, Rick? Okay, so we're going to talk about radiological risk. I'm going to turn it over to Rick at this point, and then we'll jump back and share some of these other slides as we go through the rest of the presentation.
Yeah, thank you, Bruce. As Bruce mentioned, are you all hearing me?
I don't hear you anymore.
Okay.
Oh, now I can hear you.
Okay, I'm going to see if this helps. I was hearing a bad echo that was very distracting. As Bruce mentioned, the SSSB was used for the refueling of nuclear aircraft carriers. And he also mentioned that we did a similar project, similar in the sense that we did the Sturgis that was towed from the James River down to Galveston, Texas. There were lots of differences and lots of similarities. One of the differences is that the SSSB was used for refueling. It did not contain a reactor or nuclear weapons. It was strictly used for refueling and not as a nuclear-powered naval vessel. So the process essentially was it would be docked next to an aircraft carrier. The spent fuel from the aircraft carrier would be lowered into the clean house, and I'll show you that in just a minute. Into what we call the wet pit, the big pool that Bruce talked about, where that spent fuel was disassembled and packaged into the shipping cask, and then the fuel was sent to a disposal facility in Idaho at Idaho National Laboratory. The last refueling occurred in 2015, and then the last fuel was shipped out in 2016. So there's no fuel on board. There hasn't been since 2015. The radioactive materials that are on the vessel are activation products, very little radioactive material left, and that material is primarily in the wet pit and in the water treatment systems. As Bruce mentioned, the wet pit or the fuel pool it's like a large swimming pool. It's 53 feet long, 14 feet wide, 31 feet deep, and held between 150 and 160,000 gallons of, I'll say, very cold and very clean water. So the radioactive material that remains, the most of it that remains on the vessel is in the wet pit and in the water treatment systems, the demineralizers, filters, and those kinds of things. So that's essentially the radiological hazard. And then I'll talk a little bit more about the environmental controls and monitoring that we have in place and will have in place to prevent environmental releases and environmental issues. We'll point out that a lot of the methods that we use on the radiological control side are very similar to methods that are used for common ship repair and ship breaking operations. For example, in a ship breaking operation, they have to go in and deal with lead paint and asbestos, and they use containments and filtration systems, and a lot of those things that are used to control more common hazards are also the kinds of things that we use to control radiological hazards. One of the things that Bruce mentioned is that we are working for NAVSEA, the Naval Sea Systems Command. But this is an interesting project in that even though regulatory wise and contract wise, we report and are responsible to the Navy. The Navy has a contract with the Nuclear Regulatory Commission for the Nuclear Regulatory Commission to provide decommissioning oversight. So our decommissioning work plan and other documents, radiation protection plan, and those documents have been reviewed by the Nuclear Regulatory Commission, and the Nuclear Regulatory Commission will be doing on-site inspections. We had our first meeting with them 2 weeks ago when they came on board the SSSB at Kelowna Shipyard. We also have environmental pollution liability insurance coverage. And to say a little bit about the waste, when this project is over, the SSSB will no longer exist. The definition of D&D in this case is dismantlement and disposal. So we'll take the entire vessel apart. The materials parts of the vessel that can be radiologically released, we'll have an extensive survey program in place to do that. And then the rest of the vessel will be shipped off in DOT approved containers to go to WCS. That was one of our teaming partners, the waste control specialist in Andrews, Texas. Let me give just an overview of the operation. And this is, I've got it broken down like not necessarily in chronological order. Some of these things will be happening at the same time, but sort of by systems. And before I do that, let me, I'll be referring to the clean house, which is, if you can see my pointer, this large structure on top of the SSSB. And then this is the wet pit. The wet pit, when during operations was open, it now has a plastic containment over it that was put in place when Newport News shipyard pumped it down from 150,000 gallons to 8,000 gallons. So when I refer to the clean house, it's this structure, and the wet pit is contained about right in here where the sign is on the vessel.
So
the vessel. Go ahead.
Sorry, Rick. Can you go back to that slide there, the pictures? Yeah. So just for reference, the wet pit is underneath that vinyl cover that you see. So basically that pool is down below that, and that is inside of this clean house. So the white walls that you see around the top of that vinyl cover, that's the top of the upper structure of the vessel. So just kind of an orientation for you there. Thanks, Rick.
So the ship, as it stands now, is a nuclear containment structure, and what that means is that whole structure, the clean house, and other parts of the vessel are at a negative pressure relative to outside. In other words, the direction of airflow is into that structure, and all of the air goes exhausted through high efficiency particulate air filters, or HEPA filters. And there's 2 exhaust points that are both continuously monitored from that. So it's an intact operational nuclear containment as it sits right now. And our plan is to make use of that existing containment. So when we sort of our sequence will be to go after the structures inside the wet pit. There's fuel stands or fuel racks that are in there. There's other equipment that was used to disassemble the fuel bundles and package those. We'll remove all of that, and again, that's where most of the radioactivity is going to be, is in the wet pit. We'll do that inside the existing nuclear containment. And then we will remove the remaining approximately 8,000 gallons of water using something very similar to a swimming pool vacuum. But of course, it's specially designed for cleaning spent fuel pools. And then the water treatment system that was installed by the Navy to pump down the wet pit to the current level of 8,000 gallons is still on board, still operational. We'll use that to remove the residual water. The other place where there's radioactivity is concentrated, again, is in the pump room on the demineralizers and filters. Those will be drained, plugged, and packaged inside the vessel and then removed in the packaging. There's some initials there. IMCs are intermodal containers, IP1s industrial packaging. These are DOT approved containers for transporting the materials to the waste site. And then, and I'll show you this, an animation of this a little further on, is once those systems and components are out, then what you have remaining is very lightly contaminated structural surfaces. And we will section the vessel, move that into the CS, or containment structure, which is a separate structure we're building on site. And then those sections will be size reduced and packaged for disposal. And we also go after the wet pit. There's anywhere from 2 to 4 feet of high density concrete surrounding that, and that will be cut up with a wire saw and packaged for disposal. This is shows essentially how we're going to section the SSSB. This is a 3D model. It doesn't show the complete sectioning, but what you see is these are when we get into sectioning, we'll remove the pieces beginning on the forward end. That will be moved into a containment structure that is being built on site, which is about 300 feet long, 100 feet wide, that opens, and I have an animation of that as well. But these sections will be removed and placed into the containment structure, where they'll be further size reduced to fit into waste containers.
Right, Rick, that's great. Let me just expand on that a little bit. And the reason our approach is that way is, again, for personnel safety. We want to try decommission, break the ship in as large pieces as we can, using heavy equipment and cranes to minimize the exposure of people on the ground physically using torches and whatnot. We'll have some of that, but we're trying to section the vessel in as large of pieces as possible in order to minimize the safety risk to people. And then, as Rick mentioned, we'll take these large sections and put them inside the containment structure and further size them with heavy equipment and shears and whatnot inside a controlled environment. So twofold, to minimize the risk to safety, minimize the risk to environment, get those things inside a containment structure and further size reduce there and package for shipment.
All right, thank you, Bruce. Just due to time, I'll just focus on a couple of areas on this side that may be of most interest to the people on the call. And you can read the rest of those. You'll see that we have oversight by certified safety and radiation safety professionals, but I want to talk about the environmental controls and environmental monitoring. There's really two things, and I'll show you those here in just a second. But one of the things, as Bruce mentioned, the SSSB, when it comes off the tow barge, the deck barge at Alabama Shipyard, will roll into a stormwater collection system. And I have a photo of that I'll show. And that stormwater collection system, once we start opening the SSSB and cutting off sections and exposing potentially contaminated surfaces, that collection system will be closed. Any stormwater will be collected and tested and then appropriately disposed. So the SSSB will roll into this liner area and be on blocks there. And then just to the east of that will be the confinement or containment structure that we're building. And then as far as environmental monitoring, we have already conducted a baseline survey of the decommissioning site. In other words, the area where the vessel is going to be sitting. We've done a baseline radiological survey over that entire area so that we know what the initial conditions are. And then at the end of the project, we go back once we've demobbed and removed all equipment and structures and the SSSB is no longer exists. We'll do a final survey and release of the project site and demonstrate that we didn't have an impact on the project site from a radiological and hazardous material standpoint. And the other thing that we do, and we've already started, we started on about April 23rd, is we've started our environmental monitoring program, which consists of direct radiation monitoring along the project site boundary or fence line. We're doing continuous air sampling along the fence line, and then we'll also do quarterly sediment and water sampling. So this is all part of our ongoing environmental program, and we started it, about a month, a little over a month out to establish again baseline conditions that we have at the site, and that was one of that's a standard practice and one of the things that the NRC also is interested in. And as we mentioned before, we performed a very similar project, actually with a lot more radiological hazards than this one has, with 0 notice of violations and from federal and state regulatory agencies. And of course, that's our goal here as well. This is the stormwater containment system that I was telling you about that has been installed. This is a picture of it at the Alabama shipyard. Again, the SSSB will be rolled onto this stormwater collection structure, be up on blocks, and then once we expose any potentially contaminated surfaces, this will be closed and stormwater will be collected and analyzed. This is the containment structure, again, that the pieces that I showed you earlier in that exploded view of the 3D model, those sections will go in this containment structure. Again, this is also negative pressure with HEPA ventilation, HEPA filtration on the exhaust. And you can see that this is 4 sections, and those middle sections slide over the ends. That opens it up so that we can use the cranes at Alabama Shipyard to place those sections into the containment structure where the additional sizing will take place. So that's a model of that containment structure that will be installed pretty soon at Alabama Shipyard. And Bruce, back to you.
Okay, thanks, Rick. Yeah, a lot of good information here for you. So one might ask the question, why Mobile? One of the contract, 3 bullets here. One of the contract requirements from the Navy is that this work be performed in the United States. So during the preparation phase for this project, we looked at a lot of shipyards, and so Mobile was the one that was the only one that we identified where we could stick the SSSB up on the land and do all this work out of the water. Again, less risk to the environment. Again, we appreciate having Alabama Shipyard as our partner. And so this is where we're setting up to do the work. Mobile has the infrastructure, the facilities, and the workforce. So we're going to hire a lot of folks. We're going to use recyclers in the local area. And so that, again, the shipyard, recyclers, labor availability. So again, Mobile's got some lots of positive aspects to accomplish this project. And here's just a list of some of the things that are going to be economically positive. We're going to hire a lot of people and provide training for people for this project. So when this project is done, those people will still have the skill sets and the training that we provide them for this project for more projects to come. We're going to rent hotels and apartments, and we've got a whole team of people moving to Mobile for the next 2 years. We're going to buy local materials and supplies and rent trucks and equipment and trailers and hire truck drivers and again we're going to maximize the shipyard's capabilities, the port, rail yard services. We're going to truck this material up to the railhead, stick it on train cars, and away it goes. Recycling. I mentioned all the non-impacted steel. We have a process to release that for unrestricted use. Those materials that we can, we'll be very selective about that and work closely with the NRC as we do that to make sure we're meeting all of the regulatory requirements and use recyclers in the local area. So this is the first of many Navy projects to come. And we're also working with the Mobile Chamber office on actually putting some better numbers to each of these items here to better quantify the economic benefit. I want to go back to the next to the last bullet. Prior slide, please. Rick, go back. Yeah, the first of many Navy projects to follow. Rick mentioned briefly the framework for the NRC and the Navy. This is really a different project. When the NRC typically does a facility decommissioning, normally on an NRC D&D project, a facility or a building or a piece of property is released and left in place for unrestricted public use. This one's different. As Rick mentioned, the goal of this project is to make the vessel disappear, make it go away. So when the project's done, there won't be anything left. So it's a different mindset for the NRC. It's definitely the first of its kind, a one-off. So the decommissioning work plan that we wrote per the requirements for the NRC was very unique in lots of instances. We had lots of NRC correspondence, lots of phone calls, lots of discussion during development of the decommissioning work plan, just to address the differences in what's going to be left at the end. And the goal of this project is nothing's going to be left. It's all going to be disposed of. So it's first of its kind for NAVSEA. It's the first of its kind for NRC, but there will be more to come. So we're looking forward to that. Next slide, Rick. Thanks. Stakeholder outreach. We have done a lot, and I'm sure there's callers. I can't see the total list of attendees on this call, but we have met with a lot of groups in the Mobile area. We began that effort back in December of 2019, prior to even submitting the proposal to the government on this project. And we have focused mainly on the stakeholders with respect to the scope of this project, overall execution, approach, dismantling, disposing of the vessel, where's it going to go, how's it going to be handling, regulatory oversight, the NRC's involvement, the Navy's involvement, as Rick mentioned, the initial baseline radiological survey, the area monitoring that's already underway and that we're doing on a regular basis to absolutely ensure that there's no impact to the environment based on this project. So we've done a lot of that and will continue to. We have hired a local public relations firm. JJPR is on our team as well. They're local to Mobile, and they've been extremely helpful. And you haven't seen the last of them. So we're working closely with them. And as the vessel gets closer to arriving Mobile, we'll see more engagement with our local public relations firm, JJPR. So we're really pleased to have Jennifer Jenkins and her team with us as well. So a lot of our execution approach has been driven from some of the input that we've received from stakeholders through many of our presentations and discussions with different stakeholders, the mayor's group, mayor's office, and the chamber, different medical facilities, the Coast Guard strike team. So the input that we've received and discussions we've had with many groups, we've incorporated into our approach. So we've conducted 13 in-person meetings, and with COVID, you know, the virtual platforms have been a fallback, and we've done 9 of those. So they've been very beneficial, and you can see the list of folks, elected officials, regulatory agencies, and so on. We are upcoming, we're providing radiation emergency medicine training class to Mobile emergency responders. Rick, you want to talk about that anymore, or is it pretty well
just real quick,
self-explanatory there?
I know we're about out of time, but we've already signed up 22 people from Mobile Fire and Rescue, and 4 doctors from USA Hospital, and we're still trying to line up folks from Mobile County Health Department. We have 4 slots for doctors left, and that training.
I think we lost you, Rick. You cut out. The training
It's next
is
week.
upcoming. Next week. Okay. So some contact information here as we wrap up. My information is there. I'm the project manager for this project. Rick's there. He's the certified health physicist for this project. David Lowe is the D&D director for APTIM. His information is there. Tom Godfrey, he's a local contact for you there. So, questions or comments or would like additional information, just reach out to any of us listed there, and we'll get you the information. So Jennifer, back to you on that, I guess.
Well, thank you, Bruce and Rick. This was very interesting. It's a very complex project, but I think it's going to be great for our community, and certainly the future projects as well that APTIM and others may bring in on this. Are there any questions from the audience? You can raise your hand and or put it in a chat box or speak up. I know we are at 8 o'clock, and so I know people have to get off and head on to their regular work day. So I don't see any questions right now, but you have Rick and Bruce's information. So feel free to reach out to them or reach out to me, and I can make sure your question gets sent to them. So if there's no questions, again, thank you, Spire and George Hunter. Thank you, Rick and Bruce. And y'all have a great day, and we will see you in person this summer. Thanks so much.